Hello everyone. So today we'll see the for loop with the optional else. So we have seen for loop quite a lot of times already, and so we can write a simple for say n in range, right? I can say maybe I say print n, n is going from 0 1 2 up to 11. So this one we have seen. The point here to note is that I can always put an optional, in the sense it is not we can put or we don't have to put. I can put something like print my all done, okay, something like that. If I do that, what does it do is, if this loop, once this loop is fully executed, it goes through the whole thing, this else will be executed. So what is the point, right? So what about it? So now suppose in this here, suppose I just put a break here, okay, which means n equal to 0. When after the first iteration n equal to 0, at the end of that iteration it prints and it breaks. And now if I do it, this one, see, I don't get, so this is not executed. Or even then, suppose if I do here, instead of just break immediately, I can say break if n equal to anywhere equal to, if I put n equal to maybe in the middle, right? So again it is not done. So the whole point is that if the loop breaks without completing up to 11, if this statement is executed at all, then if the break is executed, this won't be done. This otherwise also, so this is the print, this part else is only executed, the whatever comes under else will be printed or done only if this loop is going through the whole thing without any break. That is the point. So now let me do one more thing. If I do, for example, I can put, say, I write something like, I go here and I put, say, for k or something, and say range, I say something like, say if I put, say, 8, and maybe this one a couple of times, and I'm gonna indent it, right? Yes. And now what is it? So I'm gonna put here, let's change the condition. At the moment I'll do without, and you'll see, so nothing. So what is happening is k is 0 to 8, and n is, and for every k, for some k is 0, n is the one which is printed here, the inside loop variable. So n is 0 and 1, so 0 and 1, then it is done, 0 and 1, again 0 and 1, it is printing every time, all done, okay. So now I'm going to open this up. So now whenever I equal to j, which means I k, so here also yeah, n equal to j, right? So if we do k equal to n, so k is, say, 0, right, and n is 0, it is gonna break, and k equal to 1, and when n is equal to 1, it is gonna break, right? So 2 times, and all other cases the condition won't be satisfied, right? So now if I run that thing, what happens? So this is the first iteration of k equals 0, this is n equals 0, so we are only getting one value here, that's the first one, k equals 0, and when k equal to 1, you get 0 and 1, and this is executed, k equal to n. So in those both cases up to here, this loop is not executed. So now this is it was the way of showing you, so why we use it for something useful, right? Or let's do an example. For example, you know the prime numbers, right? Prime numbers, for example, so 1 is not a prime, so 2, let's start with 2. So 2 has factors 1 and 2 only, you know. So 1 and itself. 3, same thing, it has factors 1 and 3, and 11 is a prime, for example. So 1 and 11, so itself and 1, if the factors, those are only factors, that is a prime. So let us write a code how to do the prime numbers. So how do I start? For example, I can say for k, or for say m in range, I can say 10, right? So now I'm going to search for the prime numbers. This is my main prime number loop. Okay, I'm searching for prime here. So now I don't have to do 1, so I'm going to start with 2. Okay, I want to check 2 is a prime. So now what I have to do, I'm going to take n, right? For n, I want to find the factors. N in range, I can do n in range. So now I'm going to do everything except itself and 1. So I am starting with the 2. I don't want to look at the 2 as a factor, and I also don't want to look at m as a factor. So last value has to be m minus 1. So I'm going to keep it m, since range only execute up to m minus 1. So this is fine, right? So 2 and m minus 1. So for m, I'm taking between 2, from 2 to m minus 1. No, 1 is not included and m is not included. So I'm going to look it. I want to see how do I check if it's a factor. I can use the modulo operator, right? I check if m percentage, right, modulo operator, we also seen that one, equal to 0, means it is a factor, right? If that is the case, if I found a factor, I don't have to check, you know, even if there is any one of them, right, in between those numbers, so I can break it out. So suppose I don't find, suppose this loop executes without finding any factors in between the number and 1, right? Then that case, what I can do, I can put an else, and I can, oh, I found my prime. Okay, I can say found prime, right? And I can put, so m will be a prime, right? Let's see if it works at all. So so see, 2, 3, 5, everything is a prime number. So now if you want to go further and put maybe 20 or 100 or something, you know, let's put 20. So these are all prime numbers. So we have found the prime numbers, you know. So see, you can use here else. The whole point is here is that this loop is executed without break. It means that it's a prime, and if it's any break, it means we have found at least one factor in between the number and 1, you know. So this is for with an else. So we don't have to restrict ourselves to one, you know, statement. Here we can have multiple statements depending upon the code or the program that you're writing. So this is a good way of checking if the loop is executed without any breaks, and depending upon that you can code the logic here. So thank you very much for watching.